Flame. Fire changed the fate of human evolution. Evidence suggests the earliest records of human ancestors using fire around 1.7 million years ago. But to have such a convenient ignition method as I have today, less than 200 years. Undoubtedly, making fire was the first technological challenge faced by humankind. The invention of the lighter was of great significance. This was the world's first truly functional lighter. And it is consistent with the working principle of a lighter as we know it today. They are completely different. In 1823, German chemist Döbereiner, a new ignition device was invented. He placed reactive metals in acidic or alkaline solutions. Hydrogen gas is removed by metal displacement. When hydrogen encounters platinum, reacts with oxygen, thus burning instantly. That is right. This reaction takes place at room temperature. However, it will be another 3 years before the invention of modern matches. The story of how the lighter was invented before the match. That is correct. This episode's focus is not limited to talking about this type of lighter. Rather, it was to understand some of the technical applications of platinum. This lays the groundwork for the next hydrogen fuel cell tutorial, and lays the groundwork for inspiration in subsequent tutorials. That is all. Let's find out. Let's talk about the specific manufacturing process of this device. Although it is a reproduction of some old items, however, the design philosophy still follows current design aesthetics. The traditional glass containers were not continued. Instead, polymer materials such as acrylic are used. While maintaining portability, it can meet the requirements for drop resistance. Most importantly, it is easy to process. In terms of color scheme, it still features the striking blue of the channel's theme. High reflectivity of decorative part surface. It is easy to mistake it for plastic. Actually, it is for durability, anodized aluminum plate with plastic coating on the surface, emphasizing the mystery of alien technology conveyed by triangular lines. The design concept is inspired by the mathematical beauty of Lagrange points, given that the solution this device comes into contact with is somewhat corrosive. Without exception, all metal parts had a protective coating applied to their surfaces to cope with harsh usage environment. Anyone who has experience doing things themselves knows very well. Custom parts are very expensive. Use existing component solutions as much as possible during the initial design phase. Fortunately, there aren't many parts in the whole set. For some assembly structures that require tight fit, here I used epoxy resin glue for fixing. Nylon nuts and screws are used for contact with the solution. Excellent acid and alkali resistance. Some structures that require disassembly for later maintenance. Under the premise of ensuring a certain degree of sealing, I chose to use silicone curing to form the sealing gasket. Everything is ready. Döbereiner used at the time dilute sulfuric acid and zinc block. I used sodium hydroxide and aluminum. The specific approach used is not important as long as it can produce hydrogen gas. The ingenious structure of this device, the key is that it is an adaptive gas generator, internal double tube structure. When the aluminum in the inner pipe reacts with sodium hydroxide to produce hydrogen gas, when the internal pressure rises, this pressure will force the liquid to the outer layer. A drop in liquid level would prevent this reaction from taking place, so you don't need to worry about it exploding under pressure. One point worth noting is, the first time you use it, you need to repeatedly vent and react. Ensure the hydrogen purity inside the container reaches the standard, otherwise an internal deflagration will occur at the moment of ignition. These are just some of my personal life experiences. Everything went smoothly. Structural details, that is all I wanted to say.